Hi, everyone, and thank you for joining today for the Air Sensors International Conference virtual series. I'm Jennifer DeWinter, and I will be presenting on behalf of myself and my co-presenter, Felipe Aguirre, about our project involving a high-density deployment of PM2.5 sensors in the Maywood community of Southern California. And I'm an air quality scientist with Sonoma Technology. We're an environmental consulting firm headquartered in Petaluma, California, and Felipe is the executive director of Comite Pro Uno, which is a community-based environmental justice organization down in Maywood, California. So during this presentation, I will first tell you about the city of Maywood and provide an overview of the goals of the project. And I will then share the approaches that we use for the community-led PurpleAir deployment. That's the focus of this talk. And also share the valuable lessons learned by Felipe and his team while working with sensors in Maywood. And finally, we'll present some of our preliminary findings from analyzing the PurpleAir data that were collected and leave you with our preliminary conclusions. And here you see in the map the red marker that shows the location of Maywood in Southern California. So the city of Maywood is about 5 to 10 miles from downtown Los Angeles, and it's really a very densely populated community with about 30,000 residents living in just a 1.2 square mile area that is shown there in the red boundary in the image. And Maywood is an environmental justice area where 7 of the 9 census tracts are actually in the highest decile on CalEnviroScreen scores. And so the residents really are quite, disproportionately impacted by environmental pollution. And as you can see, there are a number of major pollution sources in and around Maywood. And the 710 runs along the eastern side of Maywood and serves as a major thoroughfare there between the ports and the rail facilities that are located just north of Maywood. And there are also multiple industrial facilities that are located in the neighboring city of Vernon to the north as well. And so this presentation is about the deployment of PurpleAir in Maywood, which is actually just one of the data sets that were part of a larger suite of measurements that were collected in the project in Maywood. That also included continuous metals measurements, black carbon, and then also chrome-6. And the PurpleAir were deployed in order to quantify the spatial and temporal patterns of PM2.5 around Maywood, which is ultimately important to help identify actions to reduce exposure and improve health for the residents. And the community of Maywood was and still is actively engaged in hosting and operating the PurpleAir. And education and outreach with the residents was another key objective of the project. And so Felipe really led the effort with Comite Pro Uno and also support from Coalition for Clean Air to deploy the PurpleAir in Maywood. And that was a multi-step process that included recruitment, installation, and ongoing engagement with the residents, and also with performing sensor operations and maintenance. And he was fortunately able to leverage an already active and engaged group of residents during recruitment. But he found that in-person meetings held in the homes of the residents was a key step during recruitment. And he used those meetings to explain about the project, provide background about PM2.5, and also the sensors themselves. And then, during the project, the in-home and also community meetings that continued, throughout the course of the measurements provided a forum for discussing the data as it was collected to help with community education and making the data relevant and understanding what that might mean for the residents. And so during the question and answer time here, Felipe can offer a number of insights about the lessons he and his team learned during the community-led deployment, but I'll try and summarize the highlights for now. And one of the biggest challenges during recruitment was in finding host locations that met the technology requirements of the PurpleAir. In Maywood, few of the housing units have internet or Wi-Fi, and so Felipe, ended up needing to cast sort of a wider net when trying to find host locations, and he would often evaluate 3 times as many in order to then find a single participant host. And so, and he also found, that the homeowner or primary resident may not always or actually even often be the only person needed for him to interact with. And so he would typically connect with adult children or grandchildren to support setting up the sensors. And as I mentioned, the regular monthly meetings in Maywood enabled Felipe to engage with the residents during the course of the project. And here we've listed just, several of the takeaways from those meetings, including the, community interest in fireworks, which was a specific air pollution source that they identified by looking at the data. But also, more broadly, they talked about the community's interest to make other improvements for health for the residents. And Felipe does note, though, that education and outreach would have been improved if he had more materials that were available to easily explain pollution impacts to residents. And he especially noted that needing materials that are already translated into Spanish would have been very useful, as that's the primary language spoken in Maywood. And here we just highlight several of the important actionable outcomes, which came out of the community engagement. And one of those is that the community is petitioning the city to ban fireworks. And then they're also seeking other improvements to improve public health, such as a community garden, which would make healthy organic food choices more easily available. And so now I'd like to dive into the data analysis, which is ongoing, I should say, of the PurpleAir data that were collected in Maywood. And, we've acquired 12 months worth of data from April 2019, when the sensors were first deployed, through April of 2020 for analysis. And in brief, our quality control steps included taking a look at the two channels, A and B, that are available from each of the PurpleAir for internal consistency, and then also reviewing data completeness as we were calculating averages and reviewing data outliers in the data set. And then we also developed and applied data correction factors based on a roughly 2-week data set from February 2019, when the PurpleAir were co-located with a beta attenuation monitor at South Coast AQMD monitoring site. And so the next several slides highlight some of the preliminary findings, and we focused on the corrected 60-minute averages from channel A for this presentation, so keep that in mind as we move forward through the results. And after our data quality control steps, we were able to calculate 12-month averages for 7 of the sensors with data from April 2019 to April 2020. And the mean PM2.5 across those 7 PurpleAir was 12.6 micrograms per cubic meter. And we note that, this is above the annual standard, the annual National Ambient Air Quality Standard for PM2.5, which is 12. And, we can't do a proper NAAQS evaluation, of course, with the PurpleAir, but we can say that the finding is consistent with what we've seen at, from nearby regulatory data. The latest design value for LA County is 13. And one interesting finding that we note here in this last bullet is that, and we'll elaborate on it in the next slides, but the peak concentrations were actually not where we expected. They weren't found nearest to the known large sources like the 710 or the rail yard, but we see some other much more localized hotspots, which were pretty interesting results. So here we show a map of mean PM2.5 during April to April for the 7 locations with a complete data set. And the concentrations ranged from 11.4 to 13.3. And as I mentioned, we expected to see, a more clear pattern that would suggest higher concentrations near 710, or, a gradient perhaps from the northern side of Maywood, closer to the industrial and rail, and then kind of moving southwest, concentrations getting lower. Unfortunately, we're a little limited in this view with only having 7 locations, and so that result isn't very apparent. But here we're showing the mean PM2.5 during the month of October, when we had 18 locations with a complete data set, and mean concentrations during this time period ranged from 7.4 to 12.9 across Maywood. And similarly to the 12-month result, though, a relationship with those larger known sources is not clearly, discernible. And we also don't see peak concentrations along the major roadways that run through Maywood. So along Atlantic Boulevard, which runs north-south, or along Slauson Avenue, which runs east-west there. But what's really interesting are the differences of, in some cases up to 2 micrograms between PurpleAir that are located, just a block or two apart. And a couple of those are, shown in the red circles. And so here we highlight those 2 local hotspots in a little more detail. And the first of the red circles is a set of 3 PurpleAir on the northern side of Maywood. And the 52nd and Corona location in the middle there observed a mean PM2.5 of 12.6 during October. And that was, 0.9 to 1.3 micrograms greater than its 2 neighboring locations. We're still exploring this hotspot, but, what we can say is that 52nd and Corona is most adjacent to the industrial area to the north there in Vernon, and is, perhaps, right across the road from several truck servicing businesses and other businesses, whereas those 2 neighboring PurpleAir are almost entirely residential. So that could be an explanation. And then on the southeastern side of Maywood, I'll highlight another local hotspot along 61st, which is a residential series of streets there. And the mean PM2.5 at the 61st and Prospect location in the middle was 12.9, which was actually 2 micrograms greater than the 61st and King location, which is just 1 block to the west. And so our analysis, has involved trying to determine if these are, verifiable hyperlocal hotspots, or if they're the result of bias between the sensors, perhaps, sighting differences between them, or some combination thereof. And so our approach has been to try and explore some of the patterns in the data that might suggest what's contributing to the hotspot, rather than the concentration values alone. And here you see the diurnal pattern in the time series plot for these 3 PurpleAir locations along 61st. And 61st and King is shown in the red line on the bottom. 61st and Mayflower is shown in green, and 61st and Prospect is the blue line that's on the top of the plot. And what we see in looking at the diurnal pattern is that the higher mean PM2.5 at the Prospect location appears to be perhaps due to higher concentrations seen there during the morning, so roughly 3 to 6 a.m. And that's not an increase that we see at 61st and King. And in actuality, the 61st and Prospect location is one of just a few PurpleAir locations in Maywood with a significant morning increase in PM2.5. And so, perhaps this is due to differences in traffic patterns on Prospect or nearby as compared to the other 2 locations a block or so away. And Felipe and the community members have suggested to us that this may be a route that's taken instead of, for example, Atlantic Boulevard during the morning. And so in conclusion, I just wanted to repeat that, Felipe's insights and experiences with the community-led PurpleAir deployment really offer lessons for others planning similar projects, and he can elaborate on that. And thus far, the average PM2.5 that was measured by the PurpleAir is 12.6, which is consistent with nearby regulatory data and does, suggest an important health implication being above the NACs. And finally, while we see, a 2 microgram per meter cubic range of spatial variability, it is appearing that to be driven by, very local pollution sources rather than more obviously attributable to the larger nearby sources. And so our ongoing work will be to continue to sort of tease out those fine-scale differences. And here we acknowledge the multiple collaborators involved, as well as the partner organizations of Coalition for Clean Air and LA Unified. And I'll just, conclude here and thank you for your time. And I'm looking forward to answering any questions.